All right, guys, next episode. In this episode, let's talk about TRONLESS, electronless computing, where we are and where we're taking this. So, one of the reasons that I was really interested in getting behind this technology is because while the patents that we control are patents for photonic switching, these switches become a key component in our ability to build transistors and have those transistors manage traditional computer logic. And so some of you may know, and some may not, but our current life, the cell phones, the electronics, all these things that we enjoy, basically began in 1947, with the invention of the transistor. The transistor was invented by a basic, there's always a big team, but three major name scientists who led the development of the transistor. And the chief architect was Dr. Shockley. And so I don't think anyone could argue that Dr. Shockley was a genius in his own right, but he was also a eugenicist. And among those views, he believed that, African Americans were not very intelligent, or certainly not as intelligent as whites. But his views certainly extended beyond African Americans, to other groups, women, the whole deal, the type of thing that our community has had to, listen to, deal with, and overcome for generations now. And so brilliance is still brilliance, and he still changed the world. And so the transistor gave us the modern electronics, that we know today. But that transistor is an electron transistor. So it's based on moving electrons around. The transistor that we're going to develop at TRONLESS are going to be photonic transistors. So moving from electrons to photonics has multiple benefits, including much, much smaller use of power or energy. So you're talking about a fraction of the energy used to transmit data on a photonic computing system versus one based on electrons. And so you using, and in addition to using less power, we're not pushing the electrons through a substrate when you're dealing with light spectrum. And so you produce less heat. And so the heating and cooling needs of let's say a data center that is running primarily photonic-based computing devices is going to be significantly reduced. And I think you know that the major cost in a data center is electricity and heating and cooling. And so removing cost, Ben Franklin said, a penny saved is a penny earned. And so, we've always been a company about carbon reduction. And so we are in the electric vehicle space, and that's certainly a contribution towards carbon reduction. But I think many of you may not know that actually data centers produce a significantly greater amount of carbon than even automobiles do. And so data centers struggle with their carbon footprint tremendously. And so as we start to develop these new transistors, it's going to affect almost every industry on Earth. And at some point, as the photonics generation of computing takes over, literally every device on Earth that's now running on electrons is going to somehow, some way have to transition to these new photonic based systems. So that's the gravity of what we're talking about here with these new photonic switches that we are working on. And so we have to fund this. And so that's why I came up with the idea to start to introduce the edge of that technology by putting forth first some of the companion technologies that are going to be paired with the AI. And so our AI, our computing is going to lead to a new generation of AI software that we're also developing, and also we'll be partnering with others on. But what we're going to do is give our AI an African American face. So I said in the introductory video that we'd be introducing a new digital assistant called Patrice in competition with Alexa and Siri. And so then she would be the voice, certainly all of our cars, automobiles, bikes, but also the voice of our AI. And so I've done a little video, or actually I'm going to share a little video that we made for insiders in our company, Worthington Bailey, where we're developing the technology. It was a presentation for a non-technical audience. So I'm going to share that. I'm going to give you a link in this presentation so that you can look at that. You can see some of the players who are helping us develop this technology, get a little bit more solid understanding, and then come back to the point where the significance of taking Dr. Shockley's transistor, a man who thought that we weren't very smart, and actually transitioning that technology for the next generation by making it photonic, making it 1,000 times better than the transistor that he was able to create. We think this is going to send a global message about the capability of our community and the things that we are willing to focus on, support, and to participate in. So we want you guys to be a part of it. We want you to really engage around what we're going to be talking about next. You know, this is not a deviation from what we're doing in the automobile space. You know, our automobiles already have the LiDAR and sensors and things like that. So the more advanced computing, as we start to create light-based computing and incorporating this computing into our devices, then it's going to give us the most advanced devices as well. Also, in the model of GE, you know, people compare us a lot to like a Tesla or me to like Elon Musk. I mean, certainly, there's never going to be another Elon Musk. Elon Musk is a genius, and what he's done is phenomenal. But we're going to be able to make our own space, and what I'm building is going to be something like the old GE. So we will be in the automobile space, we'll be in the mobility space, but we're also going to be in the computing space, the photonic space. That's going to lead to a new generation of AI. And one of the first things that you're going to see us build, just to demonstrate the capability of our new switches, is a crypto miner. Because a crypto miner is what's called an application-specific device. Seems complicated, but it's actually an easier thing to build. And so right now, where we are right now, our crypto miner will be probably in the neighborhood of 400 to 600 times faster than a standard crypto miner that's running an electron-based computer board. And so faster machines solves, you know, more hash rates faster, and you win more. But the significance about the photonic switch is that you get rid of the electricity costs. Crypto miners lose money because the electric bill is more than the reward. And so, again, reducing energy cost and reducing cooling costs can make even marginal crypto mining operations profitable. And that's just one example of what this new generation of technology is going to be able to accomplish. So stay tuned, keep following these videos. We're going to get deeper and deeper in our explanations so that you guys really understand who we are, why we go like a little dark sometimes, because you're like, you know, we're deep in the lab working on our next thing. And we've been developing all of these things in parallel. And it's been difficult, you know, but we are finally starting to, you know, come out and see some light, because across the board, you know, we have our prototype cars, we're launching our delivery service, you know, we're getting our trucks on the road. When we were talking about this chip, it was one thing, but now you can visit our lab in California and see a demonstration model. And so that's becoming the case with everything that we're doing. And we'll be moving all of these projects forward simultaneously. And now we're going to be asking different groups of people to join with us in different parts of our business to make wealth for yourself, but also to help us push this thing forward. So that's it for this message. And I'll be speaking with you again in the next video. Talk to you soon.